Captain, I'm getting a warning from the ship's systems evaluator. Our solar reflective finish is being eroded by micro-asteroids.
Don't worry, Feebles. This ship's hull could take on an exploding star and come away without a scratch. Besides, those micro-asteroids, as you call them, are only grains of sand. We're in an Earth sandstorm.
Phew, that's a relief.
Not so fast, Corporal. Wind-blown sand can do some surprising damage. And it's just one of the things that cause wear and tear on the Earth's surface. The rocks and soil that make up the Earth's surface are constantly being affected by a variety of forces.
I know, by the dark forces of the universe.
No, not by dark forces. By the natural forces that cause weathering, erosion, and deposition. Weathering is the breaking up of rock caused by exposure to natural forces present at the Earth's surface. Erosion is the removal and relocation of rocks and soil by these natural forces. And deposition is the depositing of these materials once they've been moved. It's where they end up. On Earth, the process of weathering, erosion, and deposition is occurring all the time. It's a cycle, and it never ends.
And just what are the forces that cause this cycle?
Well, nearly anything that rocks and soil are exposed to at the Earth's surface. Let's look at them one by one. The rocks of the Earth's surface and even man-made structures are always under attack by physical and chemical forces. There is physical weathering and chemical weathering. Physical weathering, sometimes called mechanical weathering, is literally the cracking, breaking up, and grinding down of rocks and other objects. There are different causes of physical weathering. It might surprise you to know that temperature changes are one of the most powerful forces of physical weathering. And that's especially true for rapid or extreme changes in temperature. As you know, heat makes things expand and cold makes them contract. Rapid or uneven expansion can do a lot of damage.
You mean like if someone took an ice-cold mug and then poured hot coffee into it?
Yep, it would be a shattering experience.
Yeah, and the mug didn't do too well either.
The extreme heat from forest fires can cause rocks to crack. And every day, rocks that have been chilled by the cold night air are warmed by the sunlight of the day. The outer layers of rock warm faster than the inner layers. This can cause cracking and flaking of the rock. The same thing happens in reverse as the outer layers of rock cool again at night. Cold temperatures also cause another problem for rocks. Water from rain, snow, or dew can get into the cracks in rocks. When temperatures drop at night, this water can freeze and in turn expand. This can force the cracks in the rocks to enlarge and sometimes splits the rocks wide open.
If I was a rock, I'd be afraid to sleep at night.
Rocks don't...
Joking, Captain. Just joking.
Physical weathering can also be caused by the actions of living things, organic activity, animals and plants, for instance.
How can animals and plants harm rocks?
On Earth, animals do most of their damage to rocks by digging. Some rocks are soft enough to be scratched away slowly, but more often than not, the animals dig holes in the soil near rocks. This gives air and water and temperature changes more access to rocks and can cause uneven support, leading to cracking. It can also cause rocks to topple and roll down slopes. Would you believe that plants are even more likely to break up rocks?
I'm not buying that. plants don't move.
Well, while that's true, plants do cause weathering. The roots of plants can be incredibly strong. When the tip of a root gets into a crack in a rock, it can enlarge the crack as it grows. You can see this sort of thing happening as trees lift and break apart sidewalks and roads. The force of gravity can cause rocks to fall or roll down slopes where they can break themselves apart and shatter other rocks. A powerful example of this occurred at Yosemite National Park in California, when a massive rock slide began as giant slabs of granite broke off from a cliff face and smashed into the rocks and earth below. The final force of physical weathering is abrasion, or grinding away.
Like from a sandstorm.
Yes, wind-blown sand can be very destructive. Over thousands of years, it can wear rocks down to nothing or carve them into some very interesting shapes. Abrasion also happens when rocks grind together as water moves them. This is constantly seen in rivers and along ocean shorelines. It's the reason small rocks found in these locations are rounded, and one of the reasons bigger rocks seem to have been carved and polished. Those are the causes of physical weathering: temperature, ice, organic activity, gravity, and abrasion. Now let's take a look at chemical weathering. We'll start with the liquid that's the main cause of chemical weathering on the Earth: water.
Huh? Water? But water is the basis for life on Earth. How could it be destructive?
Water will dissolve more things than any other substance on Earth, even though it sometimes takes a very long time.
It will even dissolve rocks?
Water will dissolve the minerals that hold some rocks together. When this happens, the rocks begin to crumble. Look at these odd rock formations. They were formed because the rocks that capped them didn't dissolve in rainwater as fast as the rocks that made up the pillars. As the rain slowly dissolved away all the surrounding rock, the cap rocks acted like umbrellas, sheltering the pillars below them.
Those are some heavy umbrellas.
Over many years, exposure to the weather can damage the marble rock used in sculptures. Look at this old statue and these tombstones.
Those tombstones will soon need their own tombstones.
Water can also combine with certain gases in the air to form acids. This is especially true in modern times when the pollution generated by burning fossil fuels releases large amounts of sulfur compounds into the air. Water vapor and rain combine with this chemical to form weak sulfuric acid. This is where the term acid rain comes from. Acid rain not only weathers rocks, it destroys man-made structures and kills forests and fish. Carbon dioxide is present in the air in large amounts. When carbon dioxide combines with water, it forms carbonic acid. This is called carbonation. This weak acid can still dissolve some minerals, especially calcium. It will dissolve limestone completely. This is how many underground caverns are formed. The limestone is literally dissolved away.
Are there any other kinds of acids that weather rocks?
Surprisingly, some plants create weak acids. Those crusty things often seen growing on rocks are called lichens. Lichens create weak acid, which causes chemical weathering, while the tiny roots of lichens break up rock surfaces through physical weathering. Let's see if you can guess what the final agent of chemical weathering is. It's another one you probably wouldn't expect.
Well, the first one was simple water, so, I don't know. How about air?
Correct. The oxygen in air, to be exact. The oxygen often combines with minerals or elements in rocks and changes them into other compounds, which weaken the original rock. This is called oxidation. One of the most common of these reactions happens when iron combines with oxygen to form reddish iron oxide, known as rust, which you see in the red rocks here.
5 forces of physical weathering. And now, 5 causes of chemical weathering. Water, sulfuric acid, carbonation, plant acids, and oxidation.
And remember, chemical and physical weathering are often at work at the same time.
When physical and chemical weathering combine, the results can be dramatic. These rocks owe their rounded shapes to the combined effects of physical and chemical weathering. You see, over thousands of years, ice has cracked these rocks again and again. When these cracks first form, their edges are jagged. But during these same thousands of years, a lot of rain has fallen on these rocks. And the weak carbonic acid in the rainwater has chemically dissolved the sharp edges away, giving the rocks their rounded form. Here's a well-known example of the combined forces of physical and chemical weathering. The physical weathering of blowing sand, combined with the chemical weathering caused by rain, have severely damaged the famous Sphinx in Egypt. You've seen the dramatic examples of physical and chemical weathering in nature, but you can see plenty of examples of how weathering affects man-made objects too. The oxidation of iron and steel, rust, is chemical weathering. The greenish coating on this old bell is formed by the oxidation of bronze. Stone statues and grave markers are slowly worn away by chemical weathering. Other man-made structures can be damaged by years of chemical weathering. Unprotected wood is quickly damaged by water. Scientists are continually developing new types of paint to protect wood and other materials from weathering. But paint is eventually weathered by the same forces it protects the wood from. The paint on automobiles is not only attacked by water and acids, but like the Sphinx, it can be damaged by blowing sand. As you can see, the forces of physical and chemical weathering are constantly at work on everything around us.
I bet you understand weathering pretty well now. You've seen the forces that cause weathering and just looked at some great examples of the effects of weathering. So, Feebles, now that we've seen what breaks them,
let's see what takes them.
Erosion is the transport or movement of weathered materials, and deposition is the depositing of them in a new location. Erosion carries away landscapes, and deposition builds new landscapes somewhere else. Erosion and deposition often occur simultaneously, depending on the materials being moved and the forces moving them. There are 5 major forces involved: gravity, wind, running water, waves, and glaciers. First, let's talk about gravity.
Seems like gravity is involved with everything.
Think about it. Gravity causes things to fall. It moves things.
All right, I'll give you that.
A rock rolling off a slope is eroding from the slope. It is being transported by gravity. When it finally comes to rest, possibly hundreds of meters away, it has been deposited there by the force of gravity. As we've seen, wind is an important force in weathering, but it's also an important force in erosion and deposition.
Double duty again.
Remember, to create a sandstorm, the wind has to pick up the sand in the first place. The harder the wind blows, the larger the particles of soil or sand it can carry. This transfer of soil occurs continually in open areas, such as deserts, and the deposition of this sand creates sand dunes. The same thing goes on at sandy seashores. Other areas of dry, open ground are also susceptible to this, and plowed fields can lose topsoil rapidly in a high wind. In the United States, poor farming techniques combined with years of drought and high winds to create the famous Dust Bowl of the 1930s, which lasted for nearly 10 years. Thousands of farms were ruined in Oklahoma and other Great Plains states when the dry, plowed topsoil actually blew away. In many places, up to 10 centimeters of topsoil was lost. Thousands of farmers and their families were forced to move away. Millions of other people left the Plains states. Water, or more precisely, running water, is the greatest force of erosion and deposition on Earth. The category of running water includes a lot of things. Runoff is,
Ooh, what I do when you want me to work?
well, that's true. But in terms of erosion, runoff is when the water from rain and melting snow carries rocks and sediments downhill. This can be on a limited scale or on a huge one when storms occur. Runoff can create small cuts in hillsides, and the soil from these cuts can get deposited at the base or mouth of the cut. If these cuts or gullies become larger and collect water more often, they become stream beds. The streams, and as you've seen, the rocks they carry, wear down into the ground to form small valleys. As with gullies, the material carried by streams gets deposited where the stream slows on level ground. When streams combine to form rivers, they can carve even deeper channels, and the massive amounts of rocks and sediment they move and deposit can create new landforms. These include deltas, where the rocks and soil carried by rivers have built up large areas of fertile land where the mouths of the rivers meet the sea. There's another kind of moving water besides running water.
What's that? Flying water or walking very slowly water?
It's waves. The action of waves on the shoreline never stops. This moving water and the rocks and sand it carries wears away at some parts of the shoreline and piles up sediment at others.
In today's experiment, we'll see how running water erodes different types of soil samples at different rates. For this experiment, you'll need to prepare 3 different soil samples. A sample composed of hard-packed dirt, which has been formed into balls and dried, soil mixed with rocks, and a small piece of sod, which you can easily find at a local nursery or dig up from your own backyard. Make sure the piece of sod you dig up contains plenty of vegetation with well-established roots. You'll also need 5 foam cups, 3 rulers and a roll of masking tape, a pad, a pencil, and a marker, 3 baking pans, and a pitcher of water. Use the marker to label 3 of the styrofoam cups with the numbers 1, 2, and 3. These 3 cups will hold your soil samples. Use a pencil to carefully poke 8 holes around the sides at the bottom of cups 1, 2, and 3. Now, poke 10 to 12 holes in the bottom of another cup. You'll pour water into this cup while holding it above your soil samples to simulate rainfall. We'll call this your rainmaker. Now you're ready to fill cups 1, 2, and 3 with your soil samples. Let's put your hard-packed dirt balls into cup 1, the soil and rock mixture into cup 2, and the sod into cup 3. Now, set them in the baking pan. Tape a ruler to the sides of cups 1, 2, and 3 so that one end rests evenly with the cup at the bottom. Fill a cup with water. Hold your rainmaker cup 10 centimeters, or 4 inches, above cup number 1. Slowly pour the water so that it runs through the rainmaker into soil sample 1. Repeat this procedure with sample number 2 and sample number 3. Record what happens. Did any dirt erode and flow into the baking pans? Wait 5 minutes and then pour another cup of water over each sample and record what happens. Which sample holds onto its soil the longest? And which one erodes quickest? In our experiment, the soil in the sod sample seemed to erode the least, and the loose soil mixed with rocks eroded the quickest. Why? The cup with the soil and sod is most like soil that has not been disturbed by human activity. Undisturbed soil is usually covered by vegetation with roots that hold soil in place and protect it when the rain falls. The sample of loose soil mixed with rocks is just like land that has been disturbed by farming or development. With no protective covering of plants, erosion is a sure thing.
Our final force of erosion and deposition is ice.
But ice is frozen. It doesn't move. How can it carry anything?
Have you ever heard of things called glaciers?
Oh yeah, glaciers are gigantic sheets of ice, hundreds or thousands of meters thick, that build up when yearly snows don't melt completely.
Glaciers slowly spread and slide downhill, often as much as a few meters a day. Along the way, they break away rocks and scrape them across other rocks, scouring giant valleys in the process. Where the glaciers melt and end, they deposit these rocks in massive collections called moraines.
Captain, we've seen how rocks can be weathered and how soil can be eroded by wind and water and other things. It's all part of the natural cycle. But as we've seen with the Dust Bowl, this can be a problem for people. Do they just have to take it? I mean, can't they prevent some of these things?
The more people learn about the forces of weathering, erosion, and deposition, the better prepared they are to control them. As you saw in our experiment with water and dirt, knowing how water can affect soil is very important to preventing soil erosion. For example, the Dust Bowl forced people to learn how to conserve soil on their farms. Now they don't plow in the direction that the usual winds blow, but instead across it. That way, the wind can't pick up as much soil. They also make sure to have their farms growing something, even weeds, as much as possible. The plants hold the soil when the wind blows or when it rains. In other areas, people build jetties and shore breaks to prevent beach erosion from waves. River channels may be reinforced or dredged deeper, and levees may be built to prevent damage from flooding. Dams also hold back the waters. Hillsides in populated areas or near highways are often supported with retaining walls or have rock-catching fences. Well, there you have it. You've learned that weathering, erosion, and deposition are stages in a cycle that never stops. You've seen the different types of physical weathering: temperature, ice, organic activity, gravity, and abrasion. And the 5 agents of chemical weathering: water, sulfuric acid, carbonation, plant acids, and oxidation.
That's what breaks them.
And the 5 forces of erosion: gravity, wind, running water, waves, and glaciers.
What takes them?
And deposition.
And what?
I'm dying to hear this.
What makes them, as in making new landforms?
I guess that will have to do. You've also seen how this cycle affects people and the kinds of things they can do to control it. So, any last questions?
Captain, am I going to have to polish our ship because of that sandstorm we flew through?
We'll see, Feebles. We'll see.